Hello, good morning. Sorry, I was 1 minute late, but I wanted to give you a little bit of extra time to see the brain teaser and give yourselves a time to tease your brains. Good morning, hello, and welcome. Welcome to Tuesday morning's maths lesson. Hello, hello. Nice hellos. Yeah, hey, hey. Yes, we are. Hello, hello. And it is lovely to see you. And I hope you've told all your friends and family about these lessons so they can come and join as well. So let's have a look at these brain teasers today. It's a lovely sunny day and our brains are nice and awake. So let's give it a go and have a little look. So we have started to think about fractions, and that's what we're going to do some more work on today. So I've given you a little brain teaser. One of the ones we did do at the end of last lesson, but we hadn't really done a lot of work on equivalence. And I just wanted to see if some people are a bit clearer today on it. So I know that we have done that first one before. Some of you were here, some of you weren't, but let's just have a little think about that first brain teaser. So we've got two children, Alex and Tommy, and they're both using number lines to explore equivalent fractions. Fractions that are the same. That if you had a piece of cake and your friend had another piece of cake and the fractions were described differently, but actually it was the same portion of cake, the fraction piece would not need to come. There would be no arguments, because they are equivalent, they are the same. So let's have a look at what Alex and Tommy were doing with the number lines. So Alex has said that 2/6 equals 1/3. She's saying that if you had 2/6 of a cake or 1/3 of a cake and it was your favorite cake, you wouldn't mind, because actually it would be the same size piece of cake. And she has used the number line to show that. She has used the number line to show that. So we can see that Alex has her number line, and she has put it into 3 equal pieces for the thirds and 6 equal pieces for the sixths. And we can clearly see that 2/6 does equal 1/3. Okay, Alex is right. What's Tommy's mistake? Do you agree with Tommy? And if you don't agree, because Tommy's number line looks different, doesn't it? Alex has really understood fractions, and she's really understood it's about equal pieces. What has Tommy done with his number line? What has Tommy done with his number line? Especially that top number line of Tommy's. Have a good look at that top line of Tommy's. If you just joined, hello, 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 welcome, welcome. So we're just looking at these brain teasers, and we are just looking at what Tommy has done wrong with his number line. What has he done wrong? Look at that top number line. What isn't right about that top number line of Tommy's? What isn't right? Is his number line split into equal parts? When he said that's 3/6, to the right of those 3/6, is that the same? Is that the same to the right and to the left of his 3/6? Are they equal parts? Can you see his top number line? Yeah, is not equal. He has not split that number line into equal parts. He's done, well, 2 little marks and the big mark. That section of the number line is unequal, but then when you carry on, his number line's not equal. It's all chopped up into different pieces. So he's not working with fractions. He's not working with fractions. Exactly. Tommy's number line is not equal. It's not in equal parts, is it? He's not split that number line into equal parts. So Tommy understands he needs to break things up into pieces, but he doesn't understand that fractions is about equal pieces. They must be equal. Okay, so let's have a look at the next brain teaser. Let's have a look at the next brain teaser. Use the clues to work out which fraction is being described for each shape. So one shape, it says my denominator is 6 and my numerator is half of the denominator. So if the denominator is 6, what's the numerator? If the denominator is 6 and the numerator is half of that, half of 6 is 3. So one of those shapes is 3/6. Can we work out which one is 3/6? 3/6. A half, exactly. It's not split into 6, is it? But 3/6 is equal to 1/2. So which one is the half? Which shape is the half? So we can rule that one out. Which shape is the half? Which shape is the half on there? It's the circle, isn't it? The blue circle is the half. Okay. So the next one says, I am equivalent to 4/12. 4/12. Well, what's equivalent to 4/12? What's equivalent to 4/12? 4/12 is also equal to the same relationship, remember. If I divide that by 4, I get 1. If I divide the bottom by 4, I get 12 divided by 4, 3. So where is a third on there? Where is a third? So what's it actually divided into? 2, 4, 6. It is divided into 6. So 1/3, I know what I'm seeing as 1/3 is the same as 2/6, which is the red triangle. So what else have I got? What other clue have I got? I am equivalent to 1 whole. Well, that's the whole thing. That's pretty easy, isn't it? So that's the 1 whole is the purple pentagon. Well, we can then just do the last one to check that we're correct. So I am equivalent to 2/3. So 2/3 of the way along. Well, if 1/3 is the red triangle, then 2/3 must be, and I haven't got a orange, but it must be the square. Is 2/3. Okay. So using clues. If you did not get to do that today and you didn't get to keep up, can I ask you that you please have a go at that? Because it's really important that you can apply your maths. It's really important that you can apply your maths and that you can really think about. Sometimes it's a bit hard when we're together and we're moving along, but actually if you just think and use your clues, then you will get it. Really, really important to be able to apply your maths, not just to be able to answer test questions, Now, I'm just going to fold this over. So just cut the bottom off there. So today we're going to be thinking about equivalence again, a little bit more work on equivalence. Okay, don't worry. Oh, sorry, the link went to junk. Don't worry. We can send the links out again. If you want that, just reply to the email and, that's okay. Thank you for coming. Don't worry about being late. Just always check your junk and make sure that you take it out. Okay, let's have a little look at this fraction board. I'm going to drop you down. Also, I'm just going to put you back, close this brain teaser down and then put you back onto full screen. There we are. Okay, so let's have a look at this equivalence board. Okay, so when we're thinking about fractions and we've got the numerator on the top and the denominator on the bottom, okay, the numerator tells us how many parts we've got. The denominator tells us how many equal parts that whole has been split into. So when we look at a half, we can see that it has been split into 2 equal groups. This is one of them. This is the other one. When we look to a quarter, the bottom number tells us it's been split into 4 equal groups. This is one of them. This is another one. This is another one. This is another one. We need 4 of those equal groups to equal a whole. 1, 2, 3, 4. 4 quarters are a whole. We've got eighths here. This tells us 8 equal groups. This is one of them. To make a whole, we need 8 of those 8 equal groups to come together. 1, 2, 3, 4, 5, 6, 7, 8. This has been split into 3 equal groups. This is one of them. This is another one. This is another one. The whole is 3 of them. The bigger the number at the bottom, the size of the piece. What relationship do you notice? As the number gets bigger on the bottom, what do you notice about the size of the piece? What do you notice about the size of the piece? It's going to take a while to get, it should be in focus clearly. It'll come, there we are, it just takes a little while. What do you notice? The bigger the number at the bottom, there's a quarter, there's an eighth, there's a third, there's a sixth, there's a fifth, there's a 10th, there's a 12th. What do you notice about the size of the piece? The bigger the number, the bigger the denominator, what do you notice about the size of the piece? So the bigger the denominator, the what? So in terms of relationship, the bigger the denominator, the what the fraction. The what the fraction. The smaller the fraction. So if we are talking about a cake that you like, okay, would you rather have a quarter or an eighth? If you were talking about a cake that you like, now you don't have to eat this piece of cake all at once. You can take it home and keep it and eat it. Would you rather have a quarter or an eighth? Which would be bigger? Which would be bigger? A quarter. Oh, nice and polite. Thank you. A quarter, please. Which is the bigger fraction? A quarter or an eighth? Okay. So you can quite clearly see that there's a quarter, there's an eighth, because the eighth has been split into 8 pieces. The quarter is 4. If a cake was shared by 8, you would all get less than if a cake was shared by 4. Okay. Would you rather have a third or a quarter? A third or a quarter? This is one that often confuses people. A third or a quarter? A third or a quarter? Would you rather have a third or a quarter? So we're saying a third. And just think, if you had a cake and you had to share between 3 or 4 people, if there were only 3, you would get more, wouldn't you? You would get more. Okay. Yeah. A third or a quarter. So which is bigger, a 10th or a 12th? Which is bigger, a 10th or a 12th? Which is bigger, a 10th or a 12th? That's okay. We're just looking at fractions and seeing which sizes are bigger. Which is bigger, a 10th or a 12th? Tell me the bigger fraction, a 10th or a 12th. We can see them on the board. This is a 10th. This is a 12th. So again, thinking if you had to share something between 10 or share something between 12, where would be the bigger sets? Would you get more if it was between 10, or would you get more if it was between 12? More if it's between 10 or more if it's between 12. So 1/10 is bigger than 1/12. We can see it. We can see it. 1/10 is bigger than 1/12. Which is bigger, 3/12 or 2/12? Which is bigger, 3/12 or 2/12? Which is bigger, 3/12 or 2/12? 3/12 or 2/12? Which is bigger, 3/12 or 2/12? Which is bigger? So what do we know about the numerator? As the denominator gets bigger, the fraction is smaller because you are breaking it up into smaller and smaller pieces. But when you have more of those pieces, then you have more of the amount, don't you? So if you shared a cake into 12 equal pieces, but you got to have 3 of those pieces, you'd get more cake. So that's the thing to really remember. Think about it logically. If you're breaking it into smaller pieces and more of them, the pieces get smaller. But if you have more of those pieces, you get more cake. So let's have a look on here and see if we can use this to give us some equivalence help. Can you see another fraction that is equal to a half? Can you see another fraction that is equal to a half? Can you see another fraction that is equal to a half? Thinking about that proportion. For a half, the bottom is 2 times the top, isn't it? The bottom is twice as big as the top, or the top is half of the bottom because it's breaking in 2. So it's always going to have that relationship. Yes, 6/12, half of 12 is 6. 4/8, half of 8 is 4. 7/14, half of 14 is 7. 5/10, exactly. 8/16, always going to have the same relationship. It's always going to have the same relationship. So let's use that knowledge to see if you can help me here. So I have got a half. I'll put the whole up so that you can see as well. There's my half. Oh, it's not so good on working out where you get to see it. There it is. There's my half and there's my whole. Okay, there's my half and there's my whole. Let's put that up a little bit so you can see a bit better, and it will be a bit lighter as well. That's it. There's my half and there's my whole. Okay, how many sixths pieces do I need? How many sixths pieces do I need to be equal to that half rod? How many sixths pieces do I need to be equal to that half rod? How many sixths pieces do I need to be equal to that half rod? Oh, we are going well out of focus now, aren't we? Why is that going so out of focus? I don't know why that's going so out of focus. There we are. Just focus it again so you can see. How many sixths pieces do I need to be equal to that half rod? How many sixths? Let's have a look. There's 1, there's 2, there's 3. 3/6 equals a half. 3/6 equals a half. Okay. Now I know that you might think I know these, but like I always say, it's really good to get so confident. There's a third. Okay, there's a third. How many sixths pieces do I need to be equal to 1/3? How many sixths pieces do I need to be equal to 1/3? How many sixths pieces do I need to be equal to 1/3? Okay, let's have your answers in. 2. There's 1/6. There's 2/6. 2/6 equals 1/3. 2/6 equals 1/3. Okay. Let's put a different one on there. Let's put 1/5. 1/5. How many tenths do I need to be equal to 1/5? How many tenths do I need to be equal to 1/5? How many tenths? How many tenths? Okay, 1/10, 2/10. 2/10 equals 1/5. Okay, let's do a little quiz and then we'll do some more equivalence. Let's do a little quiz. Okay, so you've done very well on the equivalence. Let's just give you a little testy. Okay, off you go. Let's just do your test. Okay, remember, you've got that grey vertical line on the right-hand side that will allow you to scroll down. Okay, the grey vertical line that will allow you to scroll down to see the other questions. Okay, the grey vertical line that will allow you to scroll down to answer the other questions. And when you've answered all three, click on submit. Okay, when you've answered all three, click on submit. When you've answered all three, click on submit. Yeah, I can see the answers coming in. Well done. I can see the answers coming in. Well done. Just having a little drink. Oh, the fraction police have arrived now. Oh, where's your police officer? Okay. Okay. There you are. In you come. The fraction police are here. Done. Yeah, we get to see the answers. I'm just going to show you. Okay, just going to show you which ones you got right, so you'll be able to see what you got right. All done. So I'm just going to move myself out of the way. Okay, so let's share your results and you can see which ones you got correct and which ones you didn't. Okay. Okay, see which ones you got right and which ones you didn't. So, okay, so not everybody got all of them right. You cannot see your results. Okay, I will, because I'm going to share them in a moment. So I'm just making sure that I've noted down so I can see who got which ones right. Okay, so some people said the equivalent to a quarter was 1/3. Now we've just seen that that's not there. And 4/12 is 1/3, not a quarter. So the first one was 2/8. Okay, which fraction is the same as 1/3? That is 4/12. That's 1/3. Okay, which fraction is the same as 3/4? The answer to that one was 6/8. So let's just share your results with you so you can see. Okay, so you can see your results. Yay. Okay, should be able to see your results. All 100%, 100%. So make sure you click submit after the test. Okay, make sure you click submit after the test. Otherwise, you won't get your results. Okay, so well done to those of you who got all of those correct. There were a few of you who didn't. And like I say, fractions can be a bit tricky. So let's just look at the equivalence, the Cuisenaire rods that I've made, and try and look and do a few more of those and try and make them a bit tricky but still with things that you can see. Okay, I am going to put 2/5 on here now. So I have got 2/5 on there. 2/5. Okay. How many tenths do I need to be equivalent to 2/5? How many tenths to be equivalent to 2/5? How many tenths to be equivalent to 2/5? How many tenths do I need? How many tenths? How many tenths do I need to be equivalent? If you got 67%, that means you got 2 right. 67% is like 2/3, 2 out of 3. How many tenths do I need to be equivalent to 2/5? So 2/5 equals how many tenths? 2/5 equals how many tenths? Well, let's just count them up and see. Let's put them on and see if you're correct. Go to my tenths pile. There's 1, there's 2, there's 3, and there is 4. 4 tenths. 4 tenths. Now, when we're looking at equivalence, we can also think about simplifying fractions. So when we simplify fractions, we want to write the fraction in its simplest form. So when we look at 4 tenths, we ask ourselves, is there anything I can do to that number 4 tenths to make it a simpler fraction? Is there anything I can do to that number to make it a simpler fraction? And when we're simplifying fractions, we need to look for the lowest common multiple. The lowest common multiple. So I look at the multiples of 4 and I look at the multiples of 10 and I say, what can I actually divide them both by? Okay, so when I look at multiples, I can divide them both by 2 because 2 is a multiple of 10 and 2 is a multiple of 4. 2, 4, 6, 8, 2, 4, 6, 8, 10. So I can divide them both by 4. 2 divided by 4 is 2. 10 divided by 4 is 5. Hey, there you go. Equivalence. Okay, the simplest fraction. So linking equivalence to simplifying. Okay, so equivalence and simplifying. Use the maths we know already. Use the maths we know already to make it easier for ourselves. So let's do that. Okay, so if I was going to put, let's have a look what I can put down now. I'm going to put 2/4 down. 2/4. There we are, 2/4. How many sixths do I need to be equivalent to 2/4? How many sixths do I need to be equivalent to 2/4? How many sixths do I need to be equivalent to 2/4? How many sixths? Oh, hang on a minute. The fraction police are coming. Hello, officer. Nothing to see here. Whoops, outy cams. Oh, you're just checking that the equivalence is being done correctly. Oh, and you also want to know if we are simplifying. Well, yes, we are, officer. That's exactly what we're doing. So you're going to stand there and watch, and you're going to leave your police car there so we all know that you're there. So how many sixths do I need to be equivalent to 2/4? Right? Think about what 2/4 is also equivalent to. Okay, and that will help you. So 2/4 equals how many sixths? 2/4 equals how many sixths? Okay. So we are going to go 1, 2, 3, 3/6. And what do we also notice that they are equal to? we also notice that they are equal to 1/2. So when we say, what is the simplest fraction that can be? The lowest common multiple. Well, the lowest multiple is 3 of 3 is 3. Does that go into 6 as well? Yes, it does. Once, it goes into 3 once, goes into 6 twice. And hey, equivalence, and also the simplest fraction, the simplest way is 1/2. So if you were at a party and somebody said, "Oh, would you like the whole cake?" and actually you only wanted half of it, it would be quite unusual, wouldn't it, if you said, "Oh, please could I have 3/6?" Because that would complicate it. Or would you like the whole chocolate bar? Oh, no, thank you. I'd only like 1/2. That's fine. But if you said, "Oh, actually, I don't want the whole thing. Can I have 2/4?" The person would think, okay, but why don't you just say 1/2? Oh, no, actually, can I have 3/6? Oh, okay. Why didn't you just say 1/2? So the simplest form of 3/6, 2/4 is 1/2. How many tenths equals 3/6? How many tenths equals 3/6? How many tenths equals 3/6? Now, if I was asked that question, I would immediately be thinking, well, 3/6 is 1/2. That's what I would be thinking to make life easier for myself. Then I would be able to think, well, and I know it's 5/10 because we're dealing with 1/2. Because we're dealing with 1/2. I would be simplifying to make it as easy as possible for myself. For myself. How many twelfths equals 5/10? How many twelfths equals 5/10? How many twelfths equals 5/10? 5/10 equals how many twelfths? How many tenths equals 5/10? How many twelfths do I need? Again, if I had that question, I would be saying, well, 5/10 is 1/2. So if I've only got half of my twelfths, half of 12 is 6. It's okay, officer. We are doing this correctly. We are doing this correctly, officer. Hey, oops, he's fallen over now. He's so shocked by the massive maths we're doing. So 6/12. 6/12. Okay, 6/12. How many eighths would be equivalent to it? How many eighths? 6/12 equals how many eighths? How many eighths? 6/12 equals how many eighths? 6/12 equals how many eighths? 6/12 equals how many eighths? 4/8. Because we are dealing with halves. 4/8. Bunch those up a little bit and then we'll see the eighths are equal. Okay, we are dealing with halves. 4/8. 4/8. So let's use that to help us with, yes, if you could just move your police van, officer, please. Thank you very much. You need to go back in. Woo, that's it, back you go. So let's have a think of where on the line these fractions would go. I'll just cover that up so we're not getting distracted by something underneath. Where on the line these fractions would go. Where on the line would we put 1/2? Where on the line would we put 1/2? Where on that line would we put 1/2? Where on that line would 1/2 go? Thinking about what we did, that line is split into 10/10, 0, and 10/10 is the same as 1 whole 1. So I could write 10/10 under there. But again, it's not the simplest way. Would you like the whole cake? Yes, I would like 10/10, please. Okay, I know what you mean, but why are you being so complicated? Okay, half of 10/10 is 5/10. So 1/2 would go there. Where would we put 1/5? Where would we put 1/5? Where would we put 1/5? I don't know what 11/1 means. Well, I do know 11/1 means 11 whole ones. So you need to think about what you're typing in. Okay, where would we put 1/5? Now this line is divided into 10 equal parts. If there were 5 equal parts, it's the same line. Okay. Let's think about our equivalence. 2/10 is the same as 1/5. 1/5 is the simplest version. Divide 10 by 2, it goes once. Divide 2 by 2, it goes once. Divide 10 by 2, it goes 5 times. Okay, we have simplified that by dividing by the lowest common multiple. Okay, so 1/5. Where would we put 2/5? 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 Thinking about the simplest form, where would we put 2/5? What is 2/5? A simpler version of. What is 2/5? A simpler version of. It's not 10/10 because 10/10 is right up here as the whole. And if you only have 2/5, you only have 2 of those 5 equal groups. You do not have the whole thing. 2/5 is the same as 4/10. Divide 4 by 2, you get 2. Divide 10 by 2, you get 5. It is a simpler version of 4/10. So if that's 1/5 and that's 2/5, where would we put 4/5? If that's 1/5 and that's 2/5, where would we put 4/5? Where would we put 4/5? 4/5 is the same as 8/10. So this line is divided into 10 equal pieces. If we were going to divide it into 5 equal pieces, then it's sort of like this, isn't it? It's sort of like this. 1/5 is twice the size of 1/10. So there's 1/5, there's 2/5, there's 3/5, there's 4/5. There's the 5 equal sections. So 1/5 ends here, 2/5 ends there, well, 3/5 ends there, 4/5 ends there. Okay, so like we said, if that was a chocolate bar and you shared it between 5, you'd get bigger pieces than if you shared it between 10. They'd be twice as big. Okay, so thinking about your fractions. So let's just think about our fractions with money. Okay, yeah, fraction, please. I can see that you're there watching over what's going on. I can see that you're there watching what's going on. So let's think about money. Let's think about sharing money. I'm going to use some pennies to start us off, and then we're going to use some other numbers. Sometimes we get a little bit confused because we start thinking about the value of the coins and we're not. Okay, so if this is 2/5 of the whole amount, how much is there all together? If this is 2/5 of the whole amount, how much would be there for the whole set? If this is 2/5 of the whole amount, these are pennies. If this is 2/5 of the whole amount, how much would be there? How much would the whole set be? This is 2/5. This is 2/5. This is 2/5. Okay, this is 2/5. This is 2/5. So how much is the whole set? This is 2/5. So 2/5 is 4p. How much is the whole set? Well, then that's 3/5, because that's 1/5. Then that's 3/5. That's 4/5. That's 5/5. So 10p. What is 1/10 of that? What is 1/10 of 10p? I've just got the light there to brighten it up a little bit. What is 1/10 of that? What is 1/10 of that set? 1/10 is 1p. 1p is 1/10. 1p is 1/10. Okay, 1p is 1/10. So 1/10 equals 1p. 1/10 equals 1p. Okay, so somebody's confused. That's the whole set, 10 pence. If we split that 10 pence into 10 equal groups, there we are, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There would be 1 pence in each group. There would be 1 pence in each group. Yeah? 1 pence in each group. How much would there be if you had 3/10? How much would there be if you had 3/10? 3/10 of 10p. How much would there be if you had 3/10? How much would there be if you had 3/10? How much would there be if you had 3/10? Okay, there's 1/10. 1, 2, 3/10. 3p. Okay, 3p. 3 pence. How much would there be if you had 7/10? 7/10. 7/10. Okay. So to work out these fractions, we need to say what is 1/10, and then what would 7 of them be? Okay, there are 10 in total. We know that 1/10 is 1, so 7/10. 1, 2, 3, 4, 5, 6, 7. If there are 7/10 over here, how many tenths are left? If there are 7/10 here, how many tenths are left? 7/10 here, how many tenths are here? How many tenths are here? Okay. So 7/10 plus how many tenths equals 10/10, which equals 1 whole, the whole set. 7/10 plus how many tenths equals 10/10. 7/10 and how many tenths equals 10/10. Yeah, 7/10 plus 3/10 equals 10/10. So if I was going to say 5/8 plus how many eighths equals 8/8, which equals a whole. Who could put the answer in for that one for me? 5/8 plus what equals 8/8? If you had 5/8, how many more eighths would you need to make a whole one? If you had 5 of them, how many more? You can use your number bonds. You can use your number bonds all of the time, but you just have to understand that is the numerator you're adding up, not the denominator. There's still eighths. 5 plus 3 equals 8. If you have 5/8 and then you had 3 more eighths, you would have the whole set. You would have the whole one. Now we have started looking at adding fractions, and we have done a little bit more work on equivalence. We're going to finish off with another little quiz, another little test. And we will do some more work next week on equivalence, ordering fractions, and adding and taking away. But all the time making sure we understand what it is we are doing until we start having those little light bulb moments like, oh, it's just like number bonds. Oh, it's just like multiplying and division. Oh, it's just because as long as we understand that we are breaking things into equal pieces and then see how many of those equal pieces we have got, then we will know it is fractions. We just need to see what we are doing all of the time. Okay, so let's finish off with another little test. Off we go. And this is asking you to think about which fraction is bigger. Okay, which fraction is bigger, which fraction is smaller. So thinking about what we just did, which fraction is bigger, which fraction is smaller. So thinking about the ratio, if you're thinking about which fraction is bigger than a half, then the top has to be more than a half of the bottom if it's going to be bigger than a half. If you're thinking about which fraction is smaller than a quarter, thinking about the ratio. It has to be a 1:4 ratio. The top has to be 4 times smaller than the bottom. Which piece of pie is more than 1/3? More than 1/3. More than 1/3. More than 1/3. Okay, just going to finish them in a moment. Okay, last 5 seconds. Okay, and we're going to stop. And we're going to share your results. Okay, so the average score was 1 out of 3. So that tells me we've still got some work to do. The average score was 1 out of 3. So we need to still do some work on seeing what is happening with these fractions. Seeing what is happening with these fractions. Okay, so if you are confident with your fractions, remember this is a year 3 and 4 lesson. So this work is exactly what year 3 and 4 should be working on. So struggling with a bit of this is exactly what should happen. If you are in year 5 and 6, then please stay on to the next lesson. If you are still struggling with what we're doing, please join the first lesson next week as well at 10 o'clock. Okay, so let's just, we've shared results. I'm going to stop sharing results. We're going to close that down and we're going to come back up to full view. Okay, so we were asked which is more than a half, which is more than a half, okay? And we had 2/4 as an answer. Well, 2/4 we can see is the same as a half. We had 5/12. Well, let me take one of you away there. We can see that 5/12 is less than a half. And we had 5/8. Well, there's 4/8 because they're the same as a half. And if we add another one, they are more than a half because 4/8 is the same as a half. So 5/8 is the one that's bigger than a half. The next question said, which is smaller than a quarter? So there's a quarter. And we could choose a half. Well, we can see a half is not smaller than a quarter. We could choose 1/4. Well, 1/4 is not smaller than a quarter. It's the same as. Or we could choose 1/8. 1/8 is smaller than a quarter because we know that 2/8 is the same as a quarter. So smaller than a quarter was 1/8. And the last question said, which is bigger than 1/3? Which is bigger than 1/3? So do we have thirds? We didn't have any on here. So there's a third. There's a third. 3/3 make 1 whole, as we know. So which is bigger than a third? 2/6. Well, no, because 2/6 is the same as 1/3, as we know. 2/6 is the same as 1/3. 1/4. Well, if we were going to share something between 4 and something between 3, between 4 would get less. So no, a quarter is smaller than a third. 1/2. If you share a chocolate bar between 2, you'll get a bigger piece than if you share it between 3. So 1/2 is bigger than a third. Okay. So well done if you got all of those correctly. Do not worry if you didn't. The whole point of this is to really help you with fractions and to do more practical work, and so that you can see the fractions and really get it into your head. Oh yeah, that looks like that. Oh yeah. And we're going to do more work on that next week. Okay. Thank you for joining me. Before we go, we did have a competition. I told you about a competition a few weeks ago, and we have drawn the winner. And the winner is aware. Oh, I've got to look through all my documents here. There it is. So a few weeks ago, I did share that we had a competition to give away. And well done to Anastasia, who lives in South London. Her and her family won the binary bot. So well done to her. I hadn't had a chance to tell my year 3 and 4s about that. So that's excellent. We will be having more giveaways. We'll be having more competitions. So do keep joining us and listening out for those. If you're staying on for the next lesson, I will see you at 12. We will be back next week. If there is any point today where you felt, oh, I'm not quite sure, please join me at 10 next week, where you can have more consolidation work. Before you go, can you just tell me something you liked about the lesson so that I can keep doing more of that, please? What did you like about the lesson? What was your best part? What did you like about it? And then I can make sure I do more of that. Okay, just tell me and I will get Rexy, who is sitting on the bed, lazy Rexy, and I'll get a well done chart. What did you like? Oh, everything. Oh, that's quite nice feedback. Thank you very much. Well, actually, not quite nice. It's lovely feedback. But the number line work. Yeah, I felt that went really, really nice. We like the number line. I'll do a few more of those. We're on the number line. Like the quiz. Yeah, I've started putting 2 quizzes in rather than just one, because I have that feedback that you like the quiz. You like the quiz, the number line. Okay, I'll make sure I do another line next week. Another number line next week, and I will just put a little mark on that now. Do another one so I don't forget, and I will make sure I keep the quizzes in. Thank you very much for joining. You take care, have a lovely day, and I will see you next Tuesday or in the next lesson if you're joining. Bye bye.